Next, we're going to look at how you multiply radical expressions. So we've added, we've subtracted. So now we're going to look at multiplying. Specifically, we're going to look at what happens when you multiply binomials. So binomials means two terms times another two terms. So when we do these, when we multiply, we are going to be doing a ton of foiling because that's what you have. You have two terms times two terms. So I'm going to take you through all the steps in foiling, what each letter FOIL stands for, and then how we simplify. So first, 4 times 5 is 20. Obviously, that one's quick because neither of them have square roots. Your outer, so when you multiply those together, you can multiply the 4s together because neither of them are inside the square root, but then we have to keep the 2 where it is. So we have 4 times 4 is 16, and we still have a root 2. Your inner, you can do the 5 times the outer 2, which is 10, and you still have a root 2. And then finally, your last, and this is where you're going to have the most work here. To do the last, you're going to have the outer 2 and the outer 4 together. So that's going to multiply to get 8. And then you're going to take the square root of 2 times another square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4, which is just 2. We talked before, when you take a square root times itself, you are just going to get that radicand number, that radicand value. So now I need to see what I can combine, just like when I do regular foiling, looking for like terms. In this case, I have like radicals. I also can combine my pieces that don't have radicals. So my 20 can combine with, over here, 8 times 2 is 16. So I'm going to put a little note above it. That's just 16. So 20 plus 16 is 36. And then I'm going to add my like radicals. 16 root 2 plus 10 root 2 is 26 root 2. And that's as far as I can go because the 36 doesn't have a radical and the 26 root 2 does. Same thing here for my FOIL. So first, 3 times 5 is 15. My outer is going to be 3 times the square root of 7. I can't multiply the 3 and the 7 together because one's in a radical and one's not. My inner is going to be a minus 5 root 7. And my last is going to be negative square root of 7 times another square root of 7, which is just 7. Again, looking for like pieces that can be combined. I like to underline them. You don't have to. So 15 minus 7, your whole pieces, the ones without the radical, gives you 8. And 3 root 7 minus 5 root 7 is negative 2 root 7. Third one's probably the most involved just because it has bigger, more numbers associated with it. It's not too much, though. 3 times 2 is 6. That's your first. Your outer, 3 times 4 is 12, and it still has a root 5. Your inner, 2 times 2 is 4, and it still has a root 5. And then your last, 2 times 4 is 8, and then the square root of 5 times the square root of 5 is just 5. I can combine my pieces without the radical. So 8 times 5 is 40. So 6 plus 40 is 46. And I can combine my radical pieces because they both are root 5. 12 plus 4 is 16 root 5. Those are all your different multiplying binomials. Now, we do have a special case. We have something called conjugates, and we've discussed conjugates before when we were talking about solutions and zeros. Conjugates are radical expressions that only differ because with the sign between them. So, for example, something like 2 plus the square root of 3 and 2 minus the square root of 3. We always said that they work together in pairs when we did solving. Multiplying conjugates is actually easier than multiplying other binomials that have radicals in it. And I'll show you why as I go through this. So 5 times 5, I'm still going to talk about foiling. 5 times 5 is 25. My outer is going to be negative 5 root 7. My inner is also going to be 5 root 7, but it's going to be positive. And then my last, square root of 7 times square root of 7, it is negative because one's positive and negative. Square root of 7 times square root of 7 is 7. And here's what happens, and this is going to happen when you work with conjugates. Your outer and your inner will be opposites and will cancel. So one's a negative 5 root 7, one's a positive 5 root 7. You're going to have your first and your last, which will combine to give us 18. And this will always be the case with conjugates. When you are multiplying conjugates, if you think about the abbreviation FOIL, your outer and your inner will cancel, giving you your first minus your last. And you will end up with just a numeric value that has no radicals in it. It's only going to happen with conjugates. I've seen students that have tried to do this with everything and not done all 4 parts of FOIL because they figured, well, it's shorter and you completely miss a couple terms. So you want to make sure you're only doing it when it's appropriate. So let me show you a few conjugates just to practice that quick process. So first, 6 times 6 is 36. Your outer and your inner will cancel. So then I'm going to go straight to my last, which is going to be minus square root of 12 times square root of 12. which is 12. This will always be minus because one will be positive and one will be negative because that's what conjugates have. And then we can combine to get 24. 3 times 3 is 9. Square root of 8 times negative square root is minus 8, which is just 1. And conjugates are the only ones that you can actually put into a calculator and get an answer because you end up with a whole number and not radicals. If you tried to do any of the earlier ones that we did that weren't conjugates, you would get a decimal value on your calculator and it wouldn't be considered a simplified answer. But conjugates, you definitely can multiply together both by hand and by calculator, and they should be pretty quick.